Okay, so for those of you who are watching this video after the fact, we started the recording 10 minutes late. I guess this is a good point. I guess we should back up then, so that the people who do watch this video after the fact get a don't miss out too much. Thanks, Jessica. Okay, so let me back up. All right, when you write this one line of code, right, we have a variable C. It gets created somewhere in memory. The new operator creates a counter object somewhere in memory. Right. So how does that happen? Well, we make a copy of the counter class and just plunk it down in memory somewhere. This counter object has a field called value, whose value is not set yet. Now the counter constructor runs. So when the counter constructor runs, it gets plunked down. It runs somewhere in memory, and it gets a variable or a parameter called this. Value of this is set to whatever the address of the newly created object was. Right, so in this case, this is the address 550. Then the constructor body runs. So in the constructor body, we have this value equals 0. So what's this? Well, this is 550. So we come up to the counter object at address 550. Right. This dot value is that field there, which we now set to 0. Now the constructor is done running. Once the constructor is finished running, new can finish running, and new returns the address of the newly constructed object. So it returns the address 550, which means the value on the right-hand side of the assignment operator, of the assignment operator here, is the address 550, which means C stores the address 550. So that's what happens when you construct, when you create and construct an object using new and a constructor. The picture here is actually a little more complicated than this. So when we talk about inheritance, this picture becomes a little bit more complicated. Now for the stopwatch class is a little bit more complicated. So just to remind you what the stopwatch does, it's supposed to emulate a physical stopwatch where you have a start button and a stop button. Right? Now, on a stopwatch, you can look at the watch and see how much time has elapsed since you pressed start, even if you haven't pressed stop yet. Right? So if you don't press any buttons, then it looks like then the stopwatch will tell you no time has elapsed. If you press the start button, wait a little while, and then look at the watch, it tells you how much time has elapsed since you pressed start. Right? If you've pressed the start button and then press the stop button, then it tells you how much time elapsed between stop and start. So in order to implement the class correctly, we need a third field that tells you whether or not the watch is running. So our no argument constructor for the stopwatch looks as follows. We're going to set the start time to 0, we're going to set the stop time to 0, and we're going to set the value of is running to false. So the watch is not running. If you compute the difference between the stop time and the start time, you get 0. That's how we're going to compute the elapsed time. So that looks fine for the stopwatch class. All right, now for the objects to be useful, we have to be able to construct or initialize an object. So we have a constructor that can do that now. But you also want to give your objects methods so that they can actually do something with the information that they have inside of them. So a method is the thing that performs some kind of computation. So far in the course, you've only implemented non-static methods, but now, you've only implemented static methods. Now remember, to use a static method, you always call the method using the name of the class. Now we're going to start implementing non-static methods. So non-static methods are much more common in Java than static methods. Non-static methods belong to or are associated with individual objects. So a non-static method can use any field belonging to an object. Right? So a non-static method for the point2 class is able to use the fields x and y. Right? For the counter class, it's able to use the field value. And for the stopwatch class, a non-static method can use the raw start time, the raw stop time, and the isRunning fields. So if I want to make a method for the point2 class that lets the user set the x and y coordinate of the point, we can implement it like so. Right? So this method here should set the x coordinate to new x, and it should set the y coordinate of the point to new y. So the implementation is simple. It's this x equals new x and this y equals new y. And then we return this in this case. I think we got to here. Now it's all coming back to me now. This is where we ended up in the last lecture. Why do we return this? It's so that you can, so what happens when you return this? You return a reference to the point that was used to call set. Words. In other words, if you write some code somewhere else, right? So if we have a point2 object called p, 2, right? Then we can call set to 1, for example, right? But this method here, because set returns a reference to the point that was called the method, right? So in other words, it returns p in this case, right? You can now call another method using the return value of set. Okay? So once again, set returns a reference to p, right? So I can set the point, and then I can do something like get its new x coordinate, like that, right? And that should give you back double new x. So that should return 1 in this case, right? Because the new x coordinate is 1. Right. So by returning a reference to the point that was used to call the method, you can chain together several method calls, which is useful for mathematical type classes. It's not so useful for other types of classes. Well, it's useful in certain circumstances. For mathematical entities, this turns out to be very useful. We can provide a method that allows the class. So the idea of these slide. So the idea of this slide is that you can provide as many methods as you want in your class. Right. So when you're designing your class, you have to decide what methods will be useful for whoever's using the class. So for the point2 class, it might be useful for the. It's certainly useful if the user can get the x coordinate of the point, or set the x coordinate of the point. So we can create a method called x that has one parameter, right? That lets you change the x coordinate of the point to new x. So the implementation is simple. It's just new x equals this x equals new x. Right? And again, we're going to return this for this particular case, so that the user can chain together several method calls. And finally, you can also provide a method that lets you set that lets the user set the y coordinate of the point. Right, and the implementation is very straightforward. Okay, so all of these methods, so set, x, and y, that change the state of the object, those are called mutator methods, right? Mutator. They're also called setters sometimes. The reason they're called setters is because they're often the name of the method is set something, right? So here is just set. We might have called x set x, and we might have called y set y. So it's very common to see these called setter methods. In general, though, they're called mutator methods, right? So any method that changes the state of the object, that's a mutator method. If you have a method that does not change the state of an object, I suppose that's not on the slide. So if it does not change the state of the object, and instead it returns information about the state of the object, then that's called an accessor method. It's sometimes called or often called a getter method. Because the name of the method often begins with get. Right? So we have x and y here, right? We might have chosen to add methods get x and get y, right? To get the x coordinate and to get the y coordinate. In the point2 class, they're just called x and y again. Here's an example of an accessor method. Right? So this is a method that returns the x coordinate. It does not change the state of the object. Right? So this x and this y are not changed by this method. So this is an accessor method. And to get the x coordinate of the point, you just return this dot x. Return the y coordinate of the point, you just return this dot y. when you write or when you define a method in your class, right, the first thing you write is what's called the method header, right? So it's the thing that looks like public point to set round bracket double x or double new x double new y. Right, so that thing there is called the header, and the header is made up of 5 individual parts. We're not going to talk about part 5 right now, so we'll talk about that a little later on. But it's made up of 5 parts. The part's called a modifier. There can be more than just one modifier on a method. For our purposes, we're only looking at the accessor, what's it officially called? Looking at the visibility modifier. So public in this case means that any class can see the set method. Second thing is usually the return type. So this says that set returns a reference to a point2 object. Right. Part 3 is the method name. In this case, it's set. Part 4 is the list and is the list of types and names of the parameters. So in this case, there's a parameter called x that's type is double. There's a parameter y whose type is double. Okay, so that's the parameter list. In the parameter list, the names of all your parameters must be unique, right? So you can't have 2 parameters with the same name, even if they have the same type. Right. Now, of course, you can have many methods that have the same parameter names, right? So, but within any one method, the name of the parameters have to be unique. Now, why am I telling you all about this? Because it turns out there's something very important about the method header. The method header defines what's called the signature of the method. So the signature of this method here, it's all of this stuff, right? So it's the name followed by the parameter list, except you don't care about the variable name, the parameter names. So it's everything not including the return type and the modifiers. That is what's called the signature. So the signature of set is set double double. Here are more examples of signatures. So for the method to uppercase, right, its signature is just to uppercase, right? No parameters, so the parameter list is empty here as well. The method car at that takes in an index, its signature is car at int, right? So that's the signature there. Right. Let's look at the fourth one. So the method get cars, it has 1, 2, 3, 4 parameters, right? So the signature of get cars is get cars, then int, array of car, and int. So get cars signature is right there. Now, why do we care about signatures? Because in Java, the signatures of the methods in the class must be unique. So we already have, the signatures have to be unique. Now, remember what the signatures are made of? They're made up of the method name, and they're made up of the types in the parameter list, right? So if the overall signature has to be unique, that means it's possible to have more than one method with the same name in a class. Right? And that turns out to be very common in Java. So it turns out to be extremely common where you have more than one method with the same name inside of a class. So for the point2 class, you could, although we're not going to, but you could introduce a second method into the class that's called set. Now the first version of set takes in 2 double values. This version of set takes in 1 double value. Right? In this case, it's taking in the x coordinate. And this method here is going to set the x coordinate to whatever value that is. And it's going to set the y coordinate to 0, apparently. Right? So we now have 2 methods called set. Right? They have different signatures. The first one, our original one, is set double double. This one is set double. Now, because signatures have to be unique, there's no way to introduce a third set method that also takes in a double value. Right? So if I wanted the companion method to this one, right, where we set the y coordinate to y and the x coordinate to 0, we can't call it set because now we have 2 methods with the same name and the same list of parameter types. That's not allowed. If you are, so when you have two methods with the same name but different signatures, those are called overloaded methods. Now you have to be careful with this term because there's another term called overridden, right? Which we've seen already when we implemented two. Have we implemented? No, we're going to see it later, right? So the term overloaded means means two methods with two or more methods with the same name in the same class. So don't confuse it with the closely related, with the similar term overridden, right? Overloaded, more than one method with the same name. So if I wanted to, I can add three methods called distance2 to the point2 class. Right? So distance2 computes the distance between a point and a second point defined by the parameters of the method. Here we have, so if you have q dot distance to p, that tells you the distance between q and p. You have q dot distance to 1, 1, that tells you the distance between q and the point 1, 1, right? Where the coordinates of the point are defined as double values. And here, if you had q dot distance to 1f, 1f, right? That tells you the distance between the point q and the point 1, 1. Where the coordinates of the point are represented using two float values. These all have different signatures, so they're all allowed to exist in the same class at the same time. Return types. So a method, in Java, a method always has a return type. If the method returns no value, then it returns void. Right? So the method X, in this case, its return type is double. Okay. So in Java, every class that you create is what's called a subclass or a child class. Subclass or child class of a class called java.lang.BigObject. Right? So that's every class. So even the ones we've created so far, those are all what are called subclasses of BigObject. Now we're going to talk about subclasses in a few weeks. Talk about inheritance. But what you need to know for now is that a class that's a subclass of some other class inherits or gets all of the methods from the class that it inherits from. Right? So every class inherits from Java.lang object. That means every class has methods that are in Java.lang object. And if you look at Java.lang object, so if you look up the documentation for the class, you'll see that there are 11 public methods in object. And that means your class that you create, so our point2, counter, and stopwatch, they all have those 11 methods already. Right? So that you get them for quote unquote free. Right? So they come from object. You get them all. You get them automatically. Most of those 11 methods we don't care about, but there are 3 that are especially important to us. So there's a method called ToString, there's a method called equals, and there's a method called hashcode. We're only looking at ToString today. Okay, so our point2 class, because it's a child class of object, it gets its own a ToString method. ToString is supposed to return some human readable representation of the object as a string. Right? So for a point, right, it would be nice, right? It would be nice if when I printed a string, I saw something like that. Right? So if I have a point -1, 1.5, when I go to print the string, or if I ask for the string representation of the point, I get something that looks like this, right? Round bracket, x coordinate, comma, space, y coordinate, closing round bracket. Now, if you actually call ToString on our point class right now, you get some gibberish, right? It doesn't look like, it does not look human readable. We just, oh, I've got it right here. Let's do this. Perfect. Okay, so here's our point2 class. All the way down here. So I'm going to comment out the current ToString. Then, sorry, let me just stick in a bunch of blank lines here. Okay. And let me comment on these lines here. Okay, so if I make a point and then print out the point, right? So when you print out a point using print line, right? So I just write print line P, right? What ends up happening is that the method, the print line, the version of print line that's called automatically calls ToString on P, right? So in other words, that, right, that line of code there is exactly the same as this line of code here. So these two lines of code mean the exact same thing, right? Which means you don't have to call ToString yourself when you go to print out an object, right? You just print out the object and you let print line call ToString automatically. Now, if we run this program, get something. Oh, why is it way up there? Sorry. Window, perspective, reset the perspective. Okay, so when we print out the point, oh, you can't see that. So what you get down here, you get the fully qualified name of the class, right? So here we get CA Queens U CS CISC 124 notes basics geometry dot point 2, right? Then you get an @ okay, and then you get a 0 in this case, right? Get a 0. So let me print out another point here. So we're just going to make another point. We're going to make a point Q, right? We'll make the point, I don't know, 1, 1. And then we'll print out Q. And let me adjust the font so that you can actually see this. I hope this changes the console font too. I don't remember if it does. Oh, it does. Good. Okay. And then let me just quickly add in some extra text so that it's clear. Okay, and we run this, right? And now you get something else, right? So you get the name, the fully qualified name of the class, followed by an @ followed by something strange. So this is what happens when you just use the version of ToString that you inherit from object, right? That thing there is related to the memory address of the object, right? It's not the, you don't know if it's the actual memory address of the object, and there's nothing you can do with it anyway, right? But that thing there is related to the memory address of the object, which is not useful, right? So that is not really a useful string representation of our object, right? It certainly is not that, right? Certainly not that. So if you want a nice string representation of your object, what you do is you replace the definition of ToString that we inherited from object, right? So replacing an inherited method is called overwriting in Java, right? So overloading two methods with the same name in the same class, right? Overwriting means we're going to replace the definition of a method that was inherited from another class, right? So here we inherited from object. I want to replace the definition of ToString that we inherited from object. Okay, and the way that you replace or override a method is you just redefine the method, right? So you take whatever the method header is that you got from object, right? So the ToString method from object is public string ToString, right? So you just write that down again, and then you redefine the body of the ToString method. So what does a ToString look like for a point2 object? Well, it's round bracket, x coordinate, comma, space, y coordinate, round bracket. So we just return the string formed with the x and y coordinates of that point. Now, what is that at override thing? Okay, so at override is what's called an annotation in Java. It's also optional. So the annotations in Java are what are they? They're actually what's called meta information. So it's information about the program. Override in this case asks the compiler to check, is this method, right? Does this method actually exist in the in one of the parent classes, right? So does this method exist in one of the classes that the point2 class inherited from? In this case, it's asking, is there actually a method public string to string in the class java.lang.object, right? If the answer is yes, everything's fine. Right? The compiler happily accepts this as an overridden method. If the answer is no, the compiler will indicate that that's an error. Right? So if you go back into the point2 class, here's our, I'm going to replace this definition here with what's on the slide. This is just a different way of implementing it using another class. Right? So we're going to return round bracket, oops, sorry, plus bracket space, comma space, plus this dot y, plus the closing round bracket. Right. So when we write ToString like that, and when we print out the point here or here or here, right, we'll end up with a string that looks like what we want. Right. So now we get this nice textual representation. Okay, so if let's take this out. So if I take out the override tag or the annotation, everything still works. Right? Program still compiles. There's no errors up here. Right? We still get the same textual output that we were looking for. Okay, so I've taken that out. I'm going to give ToString the wrong name. Right? So it's no longer a too big S string. It's now too little s string. Right? Now when I run my program, there we go. We go back to the old, we get back to the old output, right? The output that we got before we overrode ToString. Right? Now, why are we getting this? It's because we're calling the too big S string method here, right? Print line, when you give it an object, calls the too big S string method, right? And so there is no too big S string method in this class now, right? There's a too little s string, but there's no too big S string. So we end up calling the old, or the version of ToString that was inherited from object. The annotation tag, the @override tag, checks to see if this method has the correct name, the correct return type, and the correct access modifier. Right. So here you can see that Eclipse is complaining. Right. There's a light bulb with a red X beside it. You can't read that, but it says the method too little s string of type point2 must override or implement a supertype method. So what it's basically saying, there is no method called too little s string to override. Right. So this is an incorrect override. You have to fix this. That @override tag, it's there for your safety. So it forces the compiler to check whether or not this is a valid override or not. Okay, so we can skip over this. We've already done this. We've basically done this. So for the counter class, you'd also like to provide some methods, right? If you're someone using a counter, almost certainly wants the current count of the counter. So they're going to want to know what is the current value of the counter. They're going to want to be able to change the value of the counter. So increase the count by 1. And they probably want to be able to print out a counter as well. Right? So we can go ahead and add those methods now. Right? So inside the counter class, right, there is our field, there's our constructor. Here's our method called value. Right? Value returns an int. Sorry, something's going on. All right. There's our method called value. Right? Value returns an int. Right? And it just returns whatever the value of the field is. Right? So we return this dot value. To change the value of the counter by 1, right, there's a method called advance. So advance has no parameters, it returns no value. And advance, if you read its contract up here, right, it says that advance increments the value of this counter up by 1. It is called when the current value of the counter is integer max value, then the value of this counter is set to 0, right? So in other words, it wraps around to 0, right? It doesn't wrap around to integer min value, it wraps around to 0. Right? So I need to put in some code that checks if the current value is integer max value or not. Right? So if the current value is not integer max value, add 1 to the value, right? Otherwise, right, set the value to 0. So that's this advanced counter. And finally, ToString. Now, when you implement ToString, there is no quote unquote correct implementation of ToString. Right. So when you design a class, it's up to you to decide what the string representation of your object looks like. Right. It can be very complicated, or it can be very simple. Right. So for the counter class, I've decided that the ToString representation of the counter is going to be the word count, followed by a colon and a space, followed by the value of the counter. Right. And now if you print out a counter, you'll get count colon space and then the value of the counter. Right. Instead of getting some funny string produced by the ToString method from big O object. I guess I should pause there for a moment. Anybody have any questions about methods and why we implement them, and how to implement them, and so on and so forth? It's very similar to implementing a Python function. It's just that the method lives inside of a class. All right, how about stopwatch? So for the stopwatch, stop. We want methods that start the watch, stop the watch, and get the elapsed time in seconds. Okay. So I'll explain the elapsed time in seconds in a minute. Okay, so here's our fields. There is our constructor. I've got a private final static field called billion. So we're going to get the start time and the stop time using a method that returns some time in nanoseconds, right? So I want to convert those to regular seconds, which means I have to take these times and multiply them by 1 billion. Right? I don't want to write that out over and over and over again, right? In part because it's hard to count, hard to make sure that you actually have 9 zeros every time. So instead, I'm going to define a constant that's a lot easier to read. It's final, right? Remember what final means? It means once I write equals something, that's the last time I can do it. Right? I can only do that once. It's of type long because the time returned from nanotime is also a long value. Right? So it makes sense to define this as a long value. Also, that value doesn't fit in the range. Does it fit in the range? It might fit in the range of int, but the times in general returned by nanotime don't fit in the range of int. So it makes sense to define this as a long. Static. Now, static on a field means that there's only one copy of the field. So in other words, if I make 10 stopwatch objects, okay, they all have their own start time, stop time, and is running field, right? But they do not have their own field called billion. Right? So instead, this field here belongs to the class stopwatch. Individual objects do not have their own copy of this field. That's what static means. So in Java, static means the thing that's static is associated with the class and not an individual object. Right, so static methods, they're associated with the class. They're not associated with the individual objects. Right. Final, private means that you can only use this name inside of the class. You can argue that this should be public. It's not a big deal what you decide to do in this case, right? It's debatable whether or not the number 1 billion is relevant to the users of the Stopwatch class. So I decided that it's not, and I made it private. Okay, the start method. So I want to start the watch running, right? Now, if the watch is already running, then the method does nothing, right? So in other words, if you have a stopwatch, you press the start button twice, right? Nothing really happens, right? The first time you press it, the watch starts running, right? The second time you press it, depending on your watch, something may or may not happen. I've decided that nothing's going to happen. Right? That means I need some logic to check if the watch is running. So if the watch is not running, right, we're going to get the start time by calling nanotime, right? And then we're going to set is running to true. So no big deal there. Right? If the watch is running, right, we end up here and nothing happens. Now, stop the watch. Right? We're going to stop the watch and return the elapsed time in seconds since the watch was started. Right? Now, if the stopwatch is already stopped, right, then the elapsed time in seconds, as computed by this method called elapsed, is returned. So in other words, if the watch is running and you press stop, right, then we're going to tell you how much time passed between start and stop. Right. If the watch is already stopped, we're just going to return how much time had elapsed that the stopwatch. So we're going to return the amount of time that has elapsed that the stopwatch is currently showing. Okay. And so that's what the method elapsed does. So we'll look at that method in a second. If the watch is running, we'll stop the watch and we'll get the stop time. Right. Now to compute the elapsed time, you just take the stop time minus the start time. Right. And that's what elapsed is going to do. So the elapsed method returns the total amount of time in seconds that have elapsed since the stopwatch was started. Right. So if you press start and then call elapsed, it tells you how much time has passed since you pressed start. If the watch is not running, it tells you the amount of time between stopping and starting the watch. Okay, so how does this work? So we're going to compute what's called the current time, right? So that's the time at which the person has a call. Whenever you call elapsed, we're going to get what the current time is, right? Now, if the watch isn't running, I don't care about the current time, right? So if the watch is not running, I want the stop time of the watch, right? Because I want to return back how much time passed between pressing stop and start. So if the watch isn't running, we just set the current time to the stop time. Right. Now to compute the elapsed time, it's just the current time minus the start time divided by 1 billion. It's returning a double, right? So it's not returning a long, right? Which is what the start time and the start time and the stop time are represented as. Right. So it's going to return a double. So something like 1.5 seconds, for example. So I have to make sure that this arithmetic result is computed using double arithmetic, right? I didn't have the 0.0 here. It's just the current time minus the start time divided by 1 billion, right? That's long, that's long, that's a long, right? So the answer you're going to get back is a long value. And it'll be computed using some kind of integer arithmetic. Right? So for example, if there's a half a second between starting and stopping the watch, right? Then that's like 500 million divided by 1 billion, which is 0 if you do that in integer arithmetic. I don't want to return 0. I want to return the fractional value. So I have to make sure that this is computed using double. One way to do that is to make sure that the first number here is the double value 0. Right? Because that's double plus long. Java converts that to double. Right? that becomes a double minus a long. So Java converts this value to a double. Right now, this is all double divided by long. So Java converts that to a double, right, and does the whole thing using double. You could also cast that value to a double. And you can also cast this value to a double. Both of those would work. Do not cast that value to a double only. And I'll let you figure out why you shouldn't do that. Okay. Oh, wait, we're over time. So we'll talk about constructors in greater detail, I guess, in the next lecture. Anybody have any questions about today's lecture? If you haven't seen it yet, there is. Oh, wait. I wonder if you can. Hang on, let me check something. There's a sample midterm on OnQ that you can look at, but I don't know if you can look at the answers. So let me just quickly check before we go. If anybody has any questions, just unmute or type your question in the chat while I poke around on OnQ. Sample midterm. Did I do this correctly? I did not. Okay. All right, so on OnQ, under assessments, quizzes, sample midterm, you will see a sample midterm, which you can now, so if you actually click on the sample midterm, you can actually do it. So it's a quiz. Doesn't count towards your mark, obviously, but it's classified as a quiz. When you submit your quiz, you should be able to see the answers. So I'm going to start the quiz, right? I'm just going to submit it. You can see there's, it looks like there's 7 questions. There's not, because the first question is this honesty pledge here. So there's actually 6. The first 3 are very short, right? They're basically short answer, multiple choice, multi-select sort of thing. If you submit the quiz, that's fine. You can see it shows you the answers, right, when you submit it. Here, for the long answer questions, sorry, click on view feedback and you'll see the answer, right? This one looks like it has 4 answers. It's really 1 answer. For those of you who don't know, OnQ, if I create a short answer question in OnQ and ask OnQ to mark, well, OnQ will always auto mark it. It considers spaces to be important. So I have to put in every variation of spaces in the answers. Can you explain question 4? I thought all the answers were correct. I thought all the answers were correct. Question 4. You mean 3? Zach, you mean this one here? Yeah, okay. Which of the following statements is true about the following line of code? Okay, so A, B, and C, they all have primitive type, but it doesn't tell you what primitive type. So they could be int, and they could be a mix, right? So one might be an int, one might be long, one might be double, right? So this question is really getting to whether or not you understand how the different types of arithmetic work. Okay, so if A, B, and C are positive, then X is also positive. Well, it turns out that's not true because, right, so if they're positive, so if A and B are int, type int, right, then if you add 2 ints, you can overflow, right, and it becomes negative, right? So that one's gone, right? The actual types of A, B, and C do not affect the value of X. Well, that's not true, right? The actual types of A, B, and C absolutely affect the value of X, right? If A and B are int, and this overflows, you get some answer, right? If A and B are double and they have the same value, then that doesn't overflow, right? And in fact, you can compute any, if A and B are, you can compute the sum exactly. If A and B were originally, are equal to their int component, their int, what's the correct word? If they're equal to their int values, right? So that's not true. If C is the double value 2, then X is the average of A and B. Also not true, right? If A and B are int, and that sum overflows, right? Then it's not the average of A and B, right? So whatever you do, you cannot compute. So if you're implementing binary search, right, in Java, and you write a plus b divided by 2 to compute the middle index, your code will eventually fail because it's not going to compute the middle index correctly for some, if you have a lot of elements in the list or array that you're searching. So that's none of the above. Can I explain why the answer is not 110? Can you explain why it isn't 104? Did I do the arithmetic wrong? It's possible I did the arithmetic. Oh, no, I didn't do it wrong. Why would it be 104? Why it isn't 109? It is 109. Dominic, can you explain your question? Right, to do the sum, you just write them out in their floating point representation. Right, so 99.4, you just write that out as 994 times 10 to the minus 1. Okay, good. All right, yep, good. So the only thing you have to deal with here is the fact that this has 4 digits, right? And our floating point representation only has 3, right? So you have to know, I have to convert this to 3 digits. So I think we said we discard I don't remember if we said we discard the last digit or if we round, right? But in this case, it's less than 5. So no matter what, it becomes 109, and then you adjust the exponent by 1, right? To make sure it only has 3 digits. 109.4. Yeah, that's right. Okay. I guess I should have written this slightly differently. But I don't really want to go in and change that. This 109, it should be shifted 1 digit to the left. So I think that might be part of the confusion. Any other questions? Okay, I'm not seeing any. So I'll end the lecture there. And I think we have another lecture on Thursday. So I'll see you Thursday. Oh, do I have office hours? Yeah, yes, I do. If you have any questions for me, I have office hours at 4:30 today for this course. But with regards to the, oh, sorry, Daniel, I'm sorry, I did see that earlier, but a bunch of questions flew by. What level of commenting is expected? So, well-written code should be self-commenting. Right? In other words, even a moderately experienced programmer ought to be able to read well-written code and not need comments in the code. Now, if you're doing something unusual, then by all means, feel free to add in a few lines of commentary to indicate to the TA exactly what it is you're doing. Right? But otherwise, assuming you're not doing anything very, so if your method's very long, you're probably doing something a little bit odd, which means you might want to consider adding some commentary, right? So in other words, if you have a lot of if statements flying around, you might want to explain why you're using so many if statements, right? Or what each if statement is trying to do or checking for. Otherwise, you don't need any comments. It's very hard for new programmers to know what to include in a program, right? Because often for new programmers, it's useful to have lots of comments in a program, right? Because they can, because that helps them translate between the comment and the code, right? But at some point, right, it just becomes easier to read the code. It doesn't matter. You won't lose marks. Jessica, it's fine. You won't lose marks for adding comments. That's absolutely fine. One of the problems with adding lots of comment to your code is that if you go back and change your code, you have to change the comments. And a lot of time what happens is the comment doesn't get changed. So the comment no longer corresponds to the code that's written. But yeah, I understand I understand why you might wonder how much commenting is required. Right, and you may have been told in your previous courses to add lots of comments, but in a professional context, you would not. All right, I guess I should let you go, and I will see you in a couple of days or this afternoon if you have any questions. All right, thanks everybody.